In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N respectively, and the segments intersect at point M as shown. If the circumference of the circle is 96, what is the length of minor arc LN? The key to solving this problem is in understanding that a tangent approaches the circumference at an angle of 90 degrees to the radius. If we understand this, and we also know that we are dealing with a quadrilateral with angles or with corners at letters L, O, N, M. We know that the sum of angles of a quadrilateral should equal to 360. So adding each of these angles should add up to 360. We can calculate the missing angle O because we're provided angle M at 60, and we just figured out that angles N and L equal to 90. So let's write it down. Angle O plus 90, representing angle L, plus 60 representing angle M, plus 90 degrees representing angle N, should equal to 360. Using mathematical manipulation, let's isolate angle O, and by subtracting 90, 60, and 90 from the left-hand side, what we get is our angle O equals to 120 degrees. So this is a mathematical representation. Of course, we can do it in our head, and given three angles, we could just subtract from 360 the other angles, and we would get the same outcome. Our angle O equals to 120. I hope it is clear why the sum of angles of a quadrilateral equals to 360. This is a very basic characteristic of a quadrilateral. And you can think of more familiar quadrilaterals like a rectangle or a square. And in those cases, every angle equals to 90 degrees. And of course, 4 times 90 would equal to 360. So this is just an easier way to remember that a total number of angles of a quadrilateral equals to 360. Knowing that the angle O equals to 120 degrees, let's refer back to the problem and see what else we're provided. What we're told is that circumference of the circle equals to 96. And circumference is the length of the line that surrounds the circle. Given that the question asks us to find the length of the part of circumference that goes from letter L to the point N, so it's that arc that runs along the circumference. One way to find the answer would be to find what part of total circumference it represents. Given that the arc runs across the angle 120 degrees long and the full circle being 360, if we can find what part of the circle is represented by the 120 degrees, we would be able also to find what share of circumference is the arc that is covered by the angle of 120. We know that the full circle runs 360 degrees, and this is, again, a general knowledge. 360 degrees equals to full circle. Then 120 relative to 360 is the same proportion that our arc would represent relative to full circumference. So let's divide 120 by 360. And what we get is 1/3. So by using manipulation, we divide both numerator and denominator by 120. and we get 1/3. So this tells us that the angle 120 represents 1/3 of the total angle that is covered by the circle. As we discussed earlier, this also means that the length of the arc that we're interested in is also 1/3 of the total circumference. And since we're provided the length of the circumference as 96, 1/3 of that would be our answer. So let's multiply 1/3 by 96, and let's set it up as a fraction 96/3. And once we perform this calculation, our answer is 32. This is our final answer.